The following scientific and technological physics demonstration by Scott A. Stevenson is an excellent way to illustrate variances in optical energy absorption with respect to either opacity or material. This specific demonstration requires some items: a balloon pump, transparent balloon, a bit of flash paper. This can be found typically at a magician's shop, and strips of 20, a little packet for between $6 to $10. A bit of thread long enough to suspend the paper in the middle of the balloon. An intense light source. In this specific case, it's a laser, handheld laser, based upon a 12x Blu-ray disc burner diode. Then a vise. In this particular case, it's a pana vise that will be used to hold the laser in position on the target, the paper, and then a glass or something to hold the balloon and the paper target in position. So, to begin to prepare this demonstration, we must make a small hole in the paper, and we do this by folding it in half and making a small tear like so, and opening it up a bit. Now, the thread I prepared a bit by putting a loop inside of it. So all we need to do is to thread the other end of the bit of string into the hole that we made in the paper, like so. And now we're going to go ahead and feed that through the loop, the loose end. And then we want to go ahead and tighten that up. Now we don't want to tighten it too much because it's going to, the attachment point, if it's too tight, will limit the burn of the paper at that specific point, and doing so will tend to make the balloon explode, which can be entertaining but also distracting. Afterwards, we fold the paper up a little bit, and now we want to prepare the string and paper to go inside of the balloon. So we just take the loose end, and we take our two fingers and we kind of make a little space, and we roll it up a bit like so, and then we go ahead and set that aside like this. Now we take our balloon and we're going to go ahead and open it up with our fingers to the wide part of the balloon like this. And now we want to take the string, the little roll string, and the paper. We want to go ahead and introduce those into the wide part of the balloon, and then we want to make sure and hold the loose end of the thread like so. And now just straighten out the neck, making sure to hold on to the loose end of the thread. And now what we have is the little bit of string and the paper inside of the middle of the balloon. So now we take our balloon pump. Now ordinarily one might think that they can go ahead and inflate it with their breath. The problem is that that introduces moisture as well as carbon dioxide into the balloon, both of which tend to limit the chemical reaction of the flash paper burning. So it's better to use a balloon pump. It has an interesting effect. As you pump it up, the paper inside tends to dance around due to the air currents caused by the air flowing into the balloon. Now you don't want to inflate this too much, but certainly enough to make the side wall of the balloon transparent, fully transparent. And take your pump and set it aside. And so now we have the actual balloon and the paper with the thread inside. And what we need to do is we need to take the thread and pull on it a little bit while holding the seal of the balloon to not let the air out, such that we can get the paper centrally positioned inside of the balloon. We don't want it too low, we don't want it too high, because if it's too low or too high, it will tend to touch the balloon upon burning due to the outgassing of the chemical reaction of the burn. So that's decent. Now we go ahead and tie that off. Like so. And now we're going to go ahead and position that using our glass. We want to make sure that the bit of paper is hanging as best we can centrally in the balloon. Now we take our light source, again in this case it's a laser, and we put that inside of the vise, and then we get that lined up as best we can with the paper. So now what this is going to demonstrate is that the optical energy of the light will pass through the transparent balloon and it will fall upon the paper, and the paper will absorb the energy of the light while the transparent balloon will not. And because the paper will absorb the energy, it will go ahead and ignite and burn. There we go. There you have it.